Alright guys, we're starting the statistics unit. Today is day 1, and you can see here we have linear curve of best fit. You may have already seen this topic, but I want to make sure that we address it and it fits nicely in with day 2, which is quadratic curve of best fit. I've given you guys lots of opportunities to practice this. We're going to talk about it on the calculator. We're going to understand how it all works, and we'll just go from there. So on the notes, you have day 1 statistic notes, and the first thing we're going to be able to do is understand the vocab and the meaning behind where all this came from. So we want to be able to interpret points on a scatter plot, and then we're going to use the calculator to calculate lines of best fit. A scatter plot is a graph in which two sets of data are plotted as ordered pairs in a coordinate plane. And these are used to investigate a relationship between the two quantities. And, you always talk about how is math relevant. Well, any statistical or research-based field uses scatter plots. So, obviously, if you're planning on going into any research-based field or career, then certainly this will be right up your alley. Correlation describes the relationship. And it fits just like what we think of when we think of slope. So if a set of data has a positive correlation, the data is going to be focused in together and it's going to go up to the right. If it has a negative correlation, it's going to be centrally focused together and it's going to be going down to the right. And if there's no correlation, then it's going to be scattered all over the place. So take about 30 seconds and tell me if you can describe this correlations as positive, negative, or no. And then it says to describe the meaning, but we'll take care of that in a second. All right. So obviously this graph was a negative correlation. And essentially what this graph says is that as X increases, what does Y do? Well, Y decreases. And that's what makes that negative. This correlation was positive. And essentially what this is saying is that as time passed, the number of clubs increased. And so being able to describe what a graph does is a positive step towards understanding exactly what the graph is measuring. And we've talked about this before. Go ahead and do these two as well. Alright, so hopefully you took a look at these two. This first one has no correlation. So average work hours has no relationship with the year. And then this one had a negative correlation, and basically what it comes down to is as the time increased, the runner's speed decreased. Something that you need to understand about correlation: it does not prove causation. We're not saying that something causes something else. And so, you can take a look at these and I'll talk about them and you can write them down while I do them. But ear size and related to age, that typically goes up as people age. Our ears do not get bigger because we get older. And so one of the ways that we understand that is because foot size in relationship to age. Well, that's all over the map. People have different size foot, in relationship to, how old they are. And, obviously 35-year-olds have the whole range of foot size. So you can't say that, like, your ears get bigger because you get older. As we found out, ears just never stop growing for some reason. But anyway, the point is that just because there's a relationship doesn't mean that one causes the other. Alright, if the data points do not all lie on a line, but are close, we can draw a line of fit. Now it says to sketch it on the previous graph, so I'm just gonna, I've only got the, basically we'll do these two. This is the line of best fit right here, and this is the line of best fit right here. Kind of just a line right in the middle of the points. We can calculate this line using the ordered pairs from our data. So today the focus is we're going to be using our calculators to obtain a more accurate equation called a curve of best fit. This type of equation of best fit is also called a linear curve equation. I want you to think about that. Linear curve. Okay, so obviously this should help you set up to where we're going. Linear curve of best fit is a straight line, whereas quadratic curve of best fit, which is what we're going to be talking about tomorrow, is not a straight line. And that's where we have to decide which one we're using. So if it's a linear curve of best fit, we have something to use. If it's quadratic, we have another button. We have another button on the calculator to use. A couple things I want you to notice. The calculator uses the equation y equals ax plus b instead of y equals mx plus b. So the calculator uses a instead of m. It's because the calculator is trying to set us up for standard form, not necessarily slope-intercept form. The SOL could also say find the slope-intercept form of an equation for the linear curve of best fit. No matter how it's presented, we're going to be using the calculator steps we're going to go over today. Some other tips about this: when a table is horizontal, the first row is the x and the second row is the y. So you label them, okay? So this is the x and this is the y. When we put them in the calculator, the x is going to go into L1, the y is going to go into L2, which is what we're going to talk about here in a minute. When the table is vertical, the left column is the x and the right column is the y. And so it helps if you label them. You could also label them L1 and L2 to make sure you keep it straight. The one thing that I want you to notice is that the x is always going to be a time-related thing, okay? And if you've done biology or earth science or even 8th grade science, the time was always on the x. A couple of vocab words that you need to know. I don't know that it'll ever come up, but either way, I've told them to you. If you're estimating a value between two things, that's called interpolation. So if I had to estimate for the bottom set of data here, the second month, that would be called interpolation. If I need to estimate, for example, the fourth month, that is called extrapolation. And when you guys did 8th grade and 7th grade science, you knew the words inter and extra, 1 minute inside, 1 minute outside. So if the data is inside your known set of data, that's interpolation. If it's outside the known set of data, that's extrapolation. I'm going to circle this because it shows up on a quiz. Alright, so we've got the vocab down, we've got the background work done. So let's go ahead and take a look at how do we actually calculate a line or curve of best fit. And so what I've got here for us is a calculator cheat sheet to calculate lines of best fit. And so we're going to compare data related to sandwiches, basically the fat and calorie data and how those things relate to each other. So what I wanted to do is, take a look at the fat and calorie content and talk about putting it into the calculator. So we have our calculator here, and I'm going to cover up the screen for right now and just leave the directions. So the first thing we're going to do is we're going to click Stat. So we click Stat, and we're going to go ahead and edit. So we're going to go ahead and click Enter. And you can see I already have some data in here. We're going to enter the X values into L1 and the Y values into L2. Well, our X values for this one are the fat content. And so I'm going to go 9, 13, and down the list. Oop, so you got to be careful. Sometimes the enter button doesn't always go and you end up with the wrong stuff in there. Alright, I have 11 data points and there are 11 data points into my information. So then we go into L2 and we put the calories. Okay, and so they match up, and that's how I know I'm in a good spot. All right. Now, the next thing we want to do is we want to have the calculator determine the line of best fit. So we are going to click Stat, and then we're going to click the right arrow, and we're going to go to Calc. And whenever it's the linear curve of best fit, we're doing Stat 4. And so here I am, and I'm on Stat 4. And I'm going to click Enter, and it says linear regression of X plus B. So then you click Enter to calculate. And hopefully mine matches what theirs says. Now, if you notice, their calculator screen includes 2 extra things that we don't have, and you don't have to worry about those. They're not relevant to what we need right here. But the slope is the A value, and the y-intercept is the B value. And so when I write the curve of best fit, I'm going to round to the nearest thousandth. And so the curve of best fit is 11.731x plus 193.852. So we found the line of best fit. And you can use this for any set of ordered pairs. So you guys have seen a lot of problems where you guys have had to use algebra to solve. I think you're going to find is that now you're going to want to hit Stat 4 or Stat Calc 4 and do that from now on because it'll help. But anyway, what we do with this is we now use that data to predict values. So I'm going to rewrite the equation right here. And so it says find the total calories of a sandwich that has a fat of 22 grams. Well, remember we talked about fat is an X value. So I can plug 22 in for X and get an amount here. And since we are doing calories to the nearest whole number, when I get my answer, I'm just going to say that that has 452 calories. Likewise, we can plug in y if we know the calories. Now, this one is the one that causes a little bit more problems. And the reason is because the x is still left. So how do I solve this? Well, I subtract the 193 and then I divide by 11.731. So it's the undoing. Now, it has 29.5 grams of fat, so we're just going to go ahead and round that up to 30. 30 grams of fat. All right, go ahead and try to answer 3 and 4. Okay, you're supposed to pause the video so that you can answer questions number 3 and 4. And so now here you go. When I plugged in 37 for the total fat grams, I got 628 calories. So we're talking about your Big Macs. When I plugged in 250 calories for 11.731, I got 5 grams of fat. We're talking about your veggie burgers. And that makes sense. Less calories, less fat. We've got a linear curve of best fit. So on my practice, and it goes on, and I give you some different situations here. It goes right in line with that. You stat edit, make sure your data points are in there correctly, and then hit stat calc 4 to get yourself an equation. And then you're going to answer some questions. Remember, the top here is x. So when I give you 15, you're going to plug that in for x. When I give you 1,050, you're going to plug that in for y. Same thing over here. People is x, cost is y. You know, sometimes they just give you x and y. Year is x, clusters is y. Weeks is x, pounds is y. You know, like I said, double check your data points and make sure they're in there correctly, and then double check your equation and make sure you hit stat calc 4, and then everything should be fine. After you're done doing that, there's just going to be a little bit of review on what the stat plots look like and what they mean. Make sure you tell me positive or negative and tell me what's happening. And then also somewhere in here, nope, that's it. So, you know, just taking it and applying it to a stat plot. When you're done with this, check it with me, and we will move on to quadratic curve of best fit.